So far we have seen Introduction to Database Management System concepts. Today we will see Database Design with Entity Relational Model (ER model). ER model is usually the result of systematic analysis to define and describe what is important to process in area of business. It does not define business process. It only represents business data schema in graphical form. ER model is important primarily for its role in database design. It provides useful concepts that allow us to represent informal description of what users want from the database to a more detailed and precise description that we can implement it in DBMS. We begin with overview of database design. We use the company database application, then we will see ER model concepts, entities and attributes, entity types and key attributes, relationships, relationship types, weak entities, attributes in relationship types, and we will see ER diagram notations. Then we will apply all the concepts to the database application company. Let us see overview of database design. Database design process can be divided into 6 steps. ER model is more relevant to these first 3 steps. Requirements analysis. First step in designing database application is to understand what data is to be stored in database. To do that, we must first find out what the users want from this database. This is usually an informal process that involves discussions with the users and gather information from these users. Next step, conceptual design. The information gathered in requirements analysis is used to develop the high-level description of the data to be stored in the database along with constraints. This step is carried out by using ER model. Logical database design. We must choose DBMS to implement our database design and convert the conceptual database design into database schema in the data model of chosen DBMS. Here, chosen DBMS means it might be Oracle or DB2. In this course, we will consider relational DBMS. So, we need to convert ER model into a relational model. Then fourth one, schema refinement. ER diagram is just approximate description of data collected in a requirements analysis. A more careful analysis required to identify potential problems and then refine the logical schema to avoid problems. Schema refinement can be done by using normalization process. Then fifth one, physical database design. This step involves building indexes and clustering some tables. The last one, security design. In this step, we identify different user groups and different roles played by users. We must identify the part of the database that different users should be accessed and take steps to ensure that they can access only the necessary parts. Suppose if we take student and faculty, student can view results and some other information related to them. Faculty may be allowed to conduct assignments, modify the attendance and giving marks to the students. Means students are not allowed to modify the attendance and they are not allowed to change the marks of their own. Such kind of access levels will be given for each and every users. To illustrate the basic ER model concepts and their use in schema design, here we are using company database application. First, we list the data requirements for database and then create its conceptual schema with ER model concepts. Company database keeps track of company, employees, departments and projects. The company is organized into departments. Each department has name, number and an employee who manages the department. And we also keep track of the start date of the department manager, Same department may be located in several locations. Each department controls number of projects. Each project has unique name, unique number, and is located at single location. And for employee, we store each employee's social security number, address, salary, gender, and his birth date. Each employee works for one department but may works on several projects. We keep track of the number of hours per week that an employee currently works on each project. And we also keep track of the direct supervisor of each employee. Each employee may have number of dependents. For each dependent, we keep track of their name, gender, birth date, and relationship to that employee. Here dependent means their family members. This is the requirements collected from the users. Let us see some introduction to ER model concepts. ER model describes data as entities, attributes, and relationships. Let us see entities and attributes now. An entity may be defined as a thing capable of independent existence that can be uniquely identified. Means it is simply a real world object. Entity exists either physically or logically. Entity might be a physical object such as car, house, or table. In our example, employee is the entity. Or entity may be an object with conceptual existence. For example, job or course. Entities can be thought as nouns. For example, computer, employee, or a song. Each entity has attributes. Attributes are the properties that describe the entity. For example, employee entity may have the attributes name, SSN, address, gender, and birth date. Here SSN means social security number. It is like Aadhaar number. Particular entity will have value for each of its attributes. For example, if you take employee, he may have name like John Smith, SSN number like this, and address, house number, and street address and state like that, and birth date. Each attribute has value set. Like if we take birth date, it is of type date, and if we take name, which is of type string or character array, like that. Means each and every attribute will have its data type. Several type of attributes occurs in ER model. Simple versus composite, single valued versus multi-valued, stored versus derived. Let us see attribute types. Simple attribute. Most attributes have a single atomic value for particular entity. Such attributes are called simple attributes. Means simple attributes are not divisible. Employee will have SSN and he have a gender, either male or female. It is atomic value. Composite attribute. It can be divided into smaller subparts, which represents more basic attributes with independent meaning. Example, we can take address or name. Here address can be composed of simple attributes like apartment number, house number, street, city, then state, zip code, and country. Name is also combination of first name, middle name, and last name. These three are the simple attributes, and combination of these three is a full name, which is composite attribute. Single valued attributes. Each entity has a single value for attribute. For example, age. One person cannot have two values for age, but if we take suppose phone number, one person can have more than one phone. Means if you take the attribute phone, you can have more than one value. Such type of attributes are called multi-valued attributes. Composite and multi-valued attributes may be nested. Like address can be subdivided into street address, city, state, and zip code. Again, street address is divided into a number and street name and apartment number, like that. Stored and derived attributes. In some cases, two or more attribute values are related. If we take age and date of birth, both are attributes of a person, they are related. Stored attributes are attributes that supply value to another attribute. Like here, date of birth, which can supply value for age. If you want to calculate age of a person, you need to subtract this birth date from current date, then you will get the age. So here we don't need to store this age and date of birth in database. Only this birth date will be stored in the database, and this age can be calculated from birth date. So this age is called as derived attribute, and this birth date will be stored on database, so it is called stored attribute. We have already seen entities. Let us see entity type and entity set. Database usually contain group of entities that are similar. For example, company having hundreds of employees. Company database stores similar information concerning each of employees. Each employee entity share some attributes like name, age and salary, but each entity will have different value. For entity 1 or employee 1, his name is John Smith and age 55 and salary is 80k. For another entity U2, Brown is the name and his age is 40 and salary 30k. Entity type is a collection of entities that have same attributes. Means if you see this entity 1, entity 2 and entity 3, all are having same attributes, name, age and salary. So we can call all these similar entities as entity type. Here it is employee. Entity set. Group of related entities is called entity set. Here list of all the employees E1, E2, E3. We can call this entire set as entity set. We have seen attributes. An attribute of an entity type for which each entity must have unique value is called key attribute of the entity type. If you take employee, attribute SSN is the key entity, means SSN value will be unique for each employee. Key attribute may be composite. If you take example, vehicle tag number, which is comprised of number and state code. Entity type may have more than one key attribute. Like if we take department, department number can be key attribute and department name. These both are unique, so we can take anyone as a primary key. So these both are key attributes. If we take another example, car entity type, here vehicle identification number is also unique and vehicle tag number is also unique. Both can act as key attributes. In ER model, we will represent these key attributes with underline. We can divide entities into these two categories, strong entity and weak entity. Let's see strong entity. Strong entity is a entity that contains sufficient attributes to uniquely identify all its entities. Simply we can say that strong entity is nothing but an entity having primary key attribute. Weak entity. It is an entity set that does not have sufficient attributes for unique identification of its records. Means it doesn't have primary key attribute. Displaying entity types. Strong entities can be represented by using a rectangular box in ER model, and weak entities will be represented with double rectangle in ER model, and attributes are displayed with ovals, and composite attributes will be represented with oval. All its simple attributes will be connected to that composite attribute, like name, first name, middle name and last name will be connected to this composite attribute name. SSN is the key attribute. Key attributes will be underlined within the ER model, so SSN will be represented with underline. And multi-valued attributes, like suppose if you take phone number for employee, one employee can have more number of phones, so this will be represented with double oval. We discussed entities and attributes. Now we can define entity types for company database based on given requirements. Initially we have seen some requirements for example database. Company is organized into departments. Each department has name, number and employee who manages the department, and we need to keep track of the start date of the department manager. Department may have several locations. This is the information we need to represent in the database regarding department. Like that, we have other entities, projects, employee, and dependents of employee. Basically, here we have 4 entities: department, project, employee, and dependent. Let's see one by one. Department. Entity type department with attributes name, number, manager of department, and manager start date. And we already see that department can be on several locations. Here this department name and number both are key attributes because both have unique values for each department. Another entity type, project. It has attributes name, number, and location. See here, department has many locations, so which is represented with double oval. All these are simple attributes, so single oval. But when we see the requirements of project location is simple attribute. Each project has unique name and unique number and is located at single location, which is not multi-valued attribute. So here it is simple attribute, and each project will be controlled by some department, so we included this controlling department attribute in this project entity type. Both name and number separately are the key attributes. Entity type employee with attributes SSN, gender, salary, supervisor, works on, address, birthday, department, and name. Here, name is the composite attribute, which is comprised of simple attributes first name, middle name, and last name. Address may be also composite attribute, but here it is represented as simple attribute. Employee can work on several projects, so we need to store hours per week on each project employee can work on. Here, SSN is the key attribute, so it is underlined. Entity type dependent with attributes a dependent name, employee, and his gender, birth date, and relationship with employee. Here it doesn't contain any key attribute. These dependents will be identified by using the employee ID. There it is SSN. Because it doesn't have any key, it is weak entity. We will represent with double rectangle. In our initial design, we are done with these 4 entities and their respective attributes. This initial design is typically not complete. Some aspects in the requirements will be represented as relationships. ER model has 3 main concepts: entities, attributes, and relationships. Let us include these relationships. Before that, let us see what is relationship. Relationship relates two or more distinct entities with specific meaning. For example, if we see employee John Smith works on product X. This is the project. Employee Wang manages the research department. This is the relationship. Means this works on associates this employee and project, and this manages relationship associates this employee with particular department. Like entities, relationships of same type are grouped into relationship type. If we see here, this relationship R1, employee E1 working on project P1. This is the relationship. And employee E2 is working on again project P1, and E4 is working on project P3. Like all these relationships are similar. We collectively call the similar kind of relationships as relationship type works on. So, works on is relationship type in which employee and project participate. But when you see the relationship, specific employee is working on specific project. But in general, we can say that employees will be working on some project. This works on is the relationship type. Like that, managers is relationship type in which employee and department participates. Now, representing this relationship type in AR model, entities will be represented with rectangle box and attributes will be represented with oval SSN. Let us see relationships. Relationship types is displayed as diamonds. Okay, this is the relationship. Like that works on. This is another relationship which relates to entities employee and project. Degree of relationship type. Degree of relationship type is the number of participating entity types. In this relationship type manages, here two entities are participating, one is the employee, another one is the department. So degree of this manages relationship type is 2. Similarly for works on also degree is 2. Project and employee both are participating. For controls also degree will be 2. All these are the binary relationship. Based on this degree, we can divide these relationships into these many categories: binary relationship, ternary, quaternary, and n-array relationship, and unary relationship. Let's see. Employee E1 is working for department D1. This is the relationship. In this relationship, two entities are participating. One is the employee, another one is department. So it is binary relationship, and works for is binary relationship type. Similarly, if you take this supply relationship type, here three entities are participating. One is the supplier, and second entity is part, and third entity is project. Here three entities are participating in this supply relationship type. This is the ternary relationship. Relationships of higher degree. Relationship types of degree 2 are called binary relationship, and degree 3 are called ternary relationship. And if any relationship type with degree more than 2 can be called as an array relationship. Recursive relationship types. An entity will participate in relationship with itself. Such kind of relationships are called recursive relationships in different roles. If you take a supervision relationship, employee entity type participate twice in two distinct roles. One as a supervisor role, another one supervisee role. See here, employee 1, he is supervisor for employee E2, and he is also supervisor for employee E3. Means here 1 means supervisor and 2 means supervisee, means subordinate. And same employee E1 is subordinate for employee E5, but he is boss for E2 and E3. Here 1 means supervisor, 2 means supervisee or subordinate. Relationship types usually have certain constraints that limits the possible combinations of entities that may participate in corresponding relationship set. For example, suppose each employee must work for only one department. This is the constraint. We need to represent this kind of constraints while we are representing these relationships in ER model. There are two main types of relationship constraints. One is cardinality ratio and participation constraints. Collectively, these two are called structural constraints. Cardinality ratio for binary relationships. Cardinality ratio specifies the maximum number of entities of an entity type can be associated with other entity via a relationship. These are the cardinality ratios for binary relationships: 1 to 1, 1 to many, many to 1, and many to many. Let's see 1 to 1. An entity in A is associated with at most one entity in B, and an entity in B is associated with at most one entity in A. In our example database, company manages is the 1-to-1 binary relationship. Means one department can have at most one manager, and one employee cannot be manager for more than one department. See here, entity A is associated with many entities in B, and an entity in B is associated with at most one entity in A. This is 1 to many. An entity in A is associated with at most one entity in B, and an entity in B is associated with many entities in A. This is many to one type. Let's see here, an entity in A is associated with many entities in B, and an entity in B is associated with many entities in A. So it is many to many. In our example, this employee works for a department. This is many to one type, and number of employees can work for one department. The relationship type works on is of cardinality ratio m:/n, because an employee can work on several projects and project can have several number of employees. So it is m:/n. Second one, existence dependency constraint or participation constraint. It specifies minimum number of relationship instances that each entity can participate in. There are two types of participation constraints. One is total participation, another one is partial participation. Partial participation, only some of entities of an entity type can participate in relationship. In total participation, every entity within entity type participate in relationship. If you see here, all the entities, department 1, department 2, department 3, all are participating in this managers. Here this is the total participation. But if you see here, only some of the entities E3, E5 and E6 are participating in this relationship type. So this is the partial participation. Minimum cardinality is 0 for partial participation because these entities are not participating in this relationship, and minimum cardinality for total participation is 1, means all the entities will be participate in this relationship type. Notations for constraints and relationships. Let's see cardinality ratio. It is shown by placing appropriate numbers on the relationship edges. See here, employee can manage at most one department. Similarly, department can have at most one employee as manager. So it is specified as 1:1. See, this relationship type works on. Its cardinality ratio is m:n because an employee can work on several projects and project can have several employees. Let's see notations for participation constraints. We do not expect every employee to manage department. So the participation of employee in manager's relationship type is partial, represented with single line. Means some are part of set of employees are related to some department entity via managers, but not necessarily all employees. But if you take this side, each and every department will have manager. You can see here all these employee entities are not participating in this relationship managers, but all these entities, department 1, department 2, department 3 are participating in this relationship type managers. So this is the total participation represented with double line. So here it is represented with double line. Identifying relationship. A weak entity must participate in identifying relationship type with owner or identifying entity type. Dependent entity is identified by employee entity via identifying relationship type dependent of. If we refine our company database by introducing these relationships, 6 relationship types are identified. All are binary relationships. One is works for, it is between employee and department. Another one managers, it is between employee and department again. And controls, which is between department and project. And works on, which is between employee and project. Supervision, between employee and employee itself, means employee will participate as 2 roles, one is subordinate and another one is supervisor roles. And dependence of, which is between employee and dependent. So this is the entire ER diagram with constraints. Here we have these 6 relationships: works for, controls, managers and works on, and supervision and dependence of. A recursive relationship. Same entity participating in relationship with itself. One entity will participate in relationship with itself. Such kind of relationships are called recursive relationship types. Here, employee entity participate in supervision relationship with itself or in 2 different roles. One as supervisor and another one is supervising. Relationship types can also contain attributes. For example, if we take works on, hours per week is an attribute for works on relationship type. Here managers is the relationship type which has the attribute start date, which is the manager start date, and works on relationship type which has the number of hours working on some project. Each employee will be working on some number of hours on some project. So these 2 are the attributes of relationships. We have seen constraints and relationships and their notations to specify. Cardinality ratio will be specified as a numbers and participation constraints specified as lines, partial participation with single line and total participation with double line. We have another alternative notations for the structural constraints, means cardinality ratio and participation constraints will be specified combinedly. Here this notation specifies that each entity E in entity type capital E participates in at least minimum and at most maximum relationship instances in relationship type R. For example, if we see here, a department has exactly one manager and an employee can manage at most one department. We can specify this like this. Specify 0, 1 for participation of employee in managers. Here, all employees may not manage department. So, some employees manages the department, some may not manage any department. So, minimum cardinality for that will be 0. And if employee manages some department, at most he can manage only one department. So, maximum cardinality here it is 1. And specify 1, 1 for participation of department in managers. All the departments will be managed by some manager. So minimum participation here it is 1 and department can be managed by at most one employee. So maximum cardinality is also 1. See, this works for relationship type. An employee can work for exactly one department and at least he should work for one department. Minimum and maximum will be 1. And department can have n number of employees. Maximum and minimum will be either it might be 0 or 1. That constraint is not specified in requirement. So let us say each department should have at least one employee. This is alternate notation for company database by using structural constraints, min-max notation. And this is the summary. Entity can be represented with rectangle, weak entity can be represented with double rectangle, and relationship diamond, identifying relationship represented with double diamond, which will be connected to weak entity. Simple attribute represented with oval, key attribute represented with oval and underline. Multi-valued attribute will be represented with double oval. Composite attribute, simple attributes will be connected to this composite attribute. Derived attributes will be represented with a dotted oval. Total participation will be represented with this double line and partial participation with single line. And cardinality ratios will be represented as numbers. And this is the structural constraints alternative notation and max notation. In next class we will see ER to relational model conversion.